All right, so we're doing lesson 13. Lesson 13, we are doing dividing polynomials again. So most of the lesson notes for today are the same as last time. I added just a couple things at the bottom here. So just a reminder when we're dividing to make sure that we're accounting for missing exponents. And this is where it's going to be a little different from the last time. All the examples we've done so far, when we divide, we end up with the right constant term at the end, but that's not always going to happen. So if you're doing the process correctly and you don't get the correct constant term at the end, that means there's going to be a remainder, and that difference is the remainder. And we're going to write it as the remainder divided over the denominator, as an extra term, essentially. So let's take a look at the examples, and I'll show you what this means by going through an example. So I've already set up the first one here. Let me make sure I wrote it down correctly. It looks like I did. So we'll go ahead and get started. So we'll put the n, we'll put the n cubed here. So first thing, n times what is n cubed? That's going to be n squared, right? N to the first times n squared is n cubed. So I'm going to go ahead and finish out the column. So n times n squared is n cubed. 2 times n squared is 2n squared. Now I'm going to look at this diagonal here. So to go, I need 7n squared up here. So to get 7n squared, that means I need to have 5n squared here, because 5 plus 2n squared equals 7n squared. Now I'm going to do the same thing. So n times what is 5n squared? That's going to be n times 5n, right? N times n is n squared. 1 times 5 is 5. So n times 5n is 5n squared. To finish out the column, 2 times 5n is going to be 10n. Okay. We'll look at the diagonal one more time. So I have 10n, but I need 14n. So to make that happen, I need to have 4n here. Right, 10n plus 4n is 14n. We'll do this one more time. So this will have to be 4, right? N times 4 is 4n. 4 times 2 is 8. And you can see we get down to the end here. I got a constant term of 8, but the constant term in the original problem was 3. Okay, so when that happens, as it says in the lesson notes, there's a remainder. So to figure out what the remainder is, okay, I got a constant term of 8, but I need a constant term of 3. So to go from 8 to 3, that means I need to go down by 5. That's a difference of 5. So to go from 8, the constant term I got, to the constant term I need of 3, I have to go down by 5. That means my remainder is actually going to be negative 5. Yes, you can have a negative remainder. I have to go down by 5 to get the correct constant term. So to write out the answer, this is the other part of the lesson notes. My answer, remember, most of my answer is up here, so it's going to be n squared plus 5n plus 4. That's the main part of the answer. But we're not just going to write n squared plus 5n plus 4 remainder negative 5. We're not going to do that. Okay. To write the remainder, as it says in the lesson notes, we are going to basically add an extra term to the answer, and we're going to write the remainder as a fraction, where the remainder is in the numerator and the original denominator is the denominator. So my extra term is going to be minus 5, okay, over the original denominator, n plus 2. This right here is the complete answer to number 1. So we have n squared plus 5n plus 4, and then we added an extra term, minus 5, the remainder, that goes in the numerator. The denominator is the original denominator, in this case, n plus 2. So n squared plus 5n plus 4 minus 5 over n plus 2, so that we write the remainder again as a fraction, as an extra term that we've added on to our answer, where our remainder is the numerator, and then our original denominator, in this case, n plus 2, is the denominator. Okay, so that's it for number 1. Let's move ahead to number 2. Okay, same thing. Notice there's no missing exponents here, so I don't have to account for any of those. So let's go ahead and get started. So we'll put our first term here, 2p squared. So 2p times what is 2p squared? That's going to be p, right? All right, 2, and then p times p is p squared. So 2p times p is 2p squared. Negative 7 times p is negative 7p. Okay. Now I'm going to look at this diagonal. This one's a little tricky. Notice I have negative 7p, but I need positive 7p. Okay. So in order to get it so that this combines to positive 7p, this needs to be a positive 14p. Why positive 14? Because it's 14 and negative 7 equal the positive 7p? And the answer is, of course, yes. So this is going to be a positive 14p. That's the only way this could happen, so that these two things combine to 7p. Okay. Let's do this again. 2p times what is 14p? That's going to be plus 7, right? Is 2p times 7 equal to 14p? Yes. Okay. And then negative 7 times positive 7 is negative 49. Okay. And once again, notice we get a different constant term. We got a constant term of negative 49, but I need a constant term of negative 39. That means there's a remainder. Okay. So what is the remainder? Well, I got negative 49, but I need negative 39. So to go from negative 49 to negative 39, am I going to go up or down? And the answer is I'm going to go up. Okay. I'm going to go up by 10. So my remainder in this case is positive 10. To go from negative 49 to negative 39, I go up by 10. All right. So now all that's left to do is to write my answer. So my answer is up here. So p plus 7. Okay. And then I'm going to add an extra term where my remainder is the numerator and my original denominator, 2p minus 7, is the denominator. So p plus 7 plus 10 over 2p minus 7. Okay, that is your answer to number 2. Okay, number 3. First thing I notice up here, we have a missing exponent. We go from x squared, and we have a constant term, but we have no x term. So I have to rewrite this as x squared plus 0x minus 74 divided by x minus 8. So I have to account for those missing exponents before I actually go ahead and do my division. Okay, so let's do this. So x times what? X times x is x squared, right? Negative 8 times x is negative 8x. Look at my diagonal. So I have negative 8x. All right, I need to combine it with something to get 0x, so this has to be positive 8x, because negative 8x and positive 8x will give me 0x. Next, x times what is 8x? It's going to be x times 8. Right, x times 8 is 8x. Negative 8 times positive 8 is negative 64. Okay, once again, I have a remainder. Okay, so I have negative 64, but I need a constant term of negative 74. Whoops. I don't know why that happened there. So I need a constant term of negative 74, which means I have a remainder. Okay, so to go from negative 64 to negative 74, that means I need to go down by 10, right? To go from negative 64, which is the constant term I got, to negative 74, which is the constant term I need, I have to go down by 10, okay? So my remainder in this case is negative 10. Okay? The only thing that's left is to write the answer. So my answer is going to be x plus 8, right? And then as the lesson notes say, I'm going to add the extra term as a fraction. So minus, my numerator is going to be minus 10, and then my denominator is going to be the original denominator. So x minus 8. So x plus 8, and then minus 10 over x minus 8. And that right here is it for lesson 13.